Hello wonderful person, this is Anton, and today we're going to be discussing new discoveries in regards to black holes, and specifically discoveries coming from the iconic Gaia telescope. ESA's incredible telescope, essentially responsible for measuring extremely accurate motion and location of stars and a lot of other bright objects in the vicinity of planet Earth. Or to be more specific, using what's known as the astrometry technique that allows the scientists to extremely accurately measure even minute changes in various bright objects. And it's been doing so for several years, discovering incredible things in the process. But last year, in December of 2022, we've actually discussed a pretty unusual and somewhat intriguing discovery coming from this telescope that was not expected to be discovered by anyone. A discovery of a somewhat unusual black hole system where one of the objects was a star not so different from our Sun, but the other object was a black hole. Although unlike other black holes we've discovered to date, this one was literally completely invisible. Or, in more scientific terms, this was a dormant black hole. A black hole that's not emitting any light and is only visible through various gravitational observations, the result of various Einsteinian theories. And so in this video I wanted to discuss a little bit more about this new discovery, and specifically the second discovery of the second black hole, and why the scientists now believe that this is a completely new type of a black hole never seen before anywhere else. But first, I wanted to start with something a little bit different, something on a slightly different topic, and something that is even more mind-blowing. Microsoft Bing. What? Why am I talking about Bing? Okay, it's not really the Bing we're talking about. We're talking about the newly updated ChatGPT that's now part of Bing and is actually sort of mind-blowing. I wanted to show you why. Okay, quick side note. There's actually going to be a separate video on this topic exploring the current state of ChatGPT in terms of science, astronomy, and science education. And I'm actually currently making this video, and it should be on the channel sometime within the next few days, possibly in the next few weeks. Anyway, subscribe if you don't want to miss this video. But here's the real reason why I wanted to start with this and nothing else. So as I was researching this particular topic, there was actually one question that I had trouble answering, mostly because some papers had somewhat conflicting results. I wanted to find out what is the closest black hole to the solar system when it comes to what's known as X-ray binaries. Essentially these types of black holes where there are two objects, usually a black hole and a relatively large star, where the two objects interact, and the black hole ends up capturing some of the material, becoming activated or no longer dormant, and thus becoming very bright and easily visible from really far away. Here's one of the most famous ones we've talked about on the channel many times, known as SS433. This is visible in radio waves. But essentially what I wanted to find was the nearest such object discovered in the last 10 years or so. Simply because it would show us which types of black holes are a little bit more common. I'm going to explain this in a few minutes a little bit more. But essentially my question was, so what's the closest such black hole? And as I was googling this, I was not able to get the exact answer right away. And so just to test ChatGPT, I basically copy-pasted my question, which is essentially, what is the nearest X-ray binary containing a black hole, pressed enter, and waited a few seconds to get the answer right here. Now this was intriguing, it was actually well articulated, but the thing is, this answer was incorrect, because this was describing that black hole we're talking about today, or one of them. This was describing Gaia BH1, the nearest black hole to us. But it was claiming this was an X-ray binary, where it was actually producing X-rays. I'm going to be talking more about this in that next video that I mentioned, but basically ChatGPT has a tendency to be extremely confident about its somewhat wrong answers. But there is a new update in ChatGPT 4. It actually tends to self-correct and does so really well. And so here's the part that really surprised me. I basically said, "Are you sure?" Confidently, ChatGPT said, "Yes, I'm sure. The information I provided is from reliable sources. Is there anything else you would like to know?" Now this really sounds like something from Reddit, where there is someone super confident in their ability, but sometimes provides somewhat incorrect information. But I kept going. Very confidently I replied, "It's not an X-ray binary." And this really kind of blew me away. It was able to self-correct. "I apologize for the confusion. You are correct. The nearest black hole to Earth is not an X-ray binary." And then it talks more about Gaia PH1. I'll be talking about this as well, so we'll come back to this in a few seconds. But this didn't answer my question, so what is the closest X-ray binary? The next answer was a little bit more generic. It basically mentioned that there are 22 known X-ray binaries in the Milky Way, and one of them is located in Cygnus constellation. First, but not the closest. Still not really that answer I was looking for. So I wanted to confirm, is it the closest? So basically it says no, but then comes back to Gaia BH1, specifically now saying that it's not an X-ray binary, but the closest black hole. And at this point, this is actually almost like a regular conversation. So then being, what is the nearest black hole in an X-ray binary? You can kind of see that at this point I was kind of giving up. I didn't think I was able to answer this. And holy cow was I wrong. This is the 7th reply. According to a study by Santana, the nearest black hole is known as V618 Monoceros at a distance of about 3500 light years away from us. That's the answer I was looking for, and turns out that it's actually correct. The study confirms it, nothing new has been discovered since, and more importantly, it provides all the references that you can sort of use to check all of this without needing to double Google this once again. And holy cow was this shocking to me. Because now we're going to be using this answer in the video to make another point. The point that previously, binary black holes were always in X-ray binaries, mostly because they're so easy to see. But just like ChatGPT just told us, there are only 22 known to us, and the nearest one is about 3500 light years away from us. In contrast, the nearest black hole to us is actually dormant. Gaia BH1 is about 1500 light years away from us, and there are now 2 dormant black holes, with the second one, the one that was just recently discovered, now being the 3rd closest black hole at approximately 3800 light years away. And here's why this is important. These discoveries suggest that these unusual black holes are most likely the most common type of black holes, the solar mass black holes, in the entire galaxy. But because they're dormant, they're most likely going to be extremely difficult to find. Here's actually the list of the nearest black holes known to us, and the top 3 are basically that X-ray binary and 2 dormant black holes, both discovered in the last few months. All of the other black holes are essentially X-ray binaries as well, and are at much farther away distances. In case you're wondering, in our galaxy, so far this one is the farthest. It's about 30,000 light years away from us. But this new study that you can find in a description now discovers that second object known as Gaia BH2, another dormant black hole with very similar properties to the first black hole BH1, but extremely different to everything else. And because of this, currently the scientists have absolutely no idea how these black holes came to be. Their actual origin story makes no sense, or at least has no explanation. But I guess first let's talk about what's in these systems. So both systems, Gaia BH1 and Gaia BH2, are really similar to one another. They're both located in a binary system with a star in a somewhat eccentric orbit around a black hole. The first black hole discovered, Gaia BH1, is roughly around 9.6 solar masses in mass, with a Schwarzschild radius of about 26 kilometers. The second black hole is just a little bit smaller at 8.9 solar masses, and is slightly smaller in size as well. But both contain a star in a somewhat eccentric orbit, and a star that's very similar in mass to our own Sun. In the first star system, this is actually already a red giant, with a star that's about 1.07 solar masses, but it's about 8 times bigger than our Sun, with a slightly lower temperature of about 4300 Celsius. Essentially, this is what our Sun might become in the next few billions of years. But in the second system, the star is a little bit smaller at 0.93 solar masses, and the radius here is almost exactly as our Sun, with very similar temperature at 5600 Celsius. Or basically both of these systems contain relatively rare G-type stars, and stars that are so similar to our Sun. Although I guess the distance to the black hole is maybe a little bit different. In BH1 system, the orbit takes approximately 186 days, and eccentricity is about 0.45. What exactly causes this unusual eccentricity, which by the way is really high for stars and for planets, is of course currently unknown. In contrast, Gaia BH2 takes about 3.5 years to orbit around the black hole, with a slightly higher eccentricity of 0.5. And so for some reason the properties here are just extremely similar. Very similar stars, very similar orbits, and both black holes seem to be dormant. And in this case, because this was Gaia looking for these objects, it only discovered them because of these minute changes in the motion of the stars across the night skies. This is what we refer to as astrometry. When it comes to, for example, planets discovered this way, only 2 so far have been found, and that's out of thousands of planets discovered using other methods. But in this case, these stars were actually wobbling way too much. It could not be a planet. They were shifting enough for this to be an actual different object, much more massive than the star itself. And because of this apparent motion, the only natural explanation was that there was a really massive, somewhat invisible object that could only possibly be some kind of a black hole. And so because of this confirmation, it now becomes a new mystery. What exactly formed these black holes and these unusual star systems? Why exactly do both contain a G-type Sun-like star with a very eccentric orbit? Why are those stars so far away from the black hole? And the main question, how did these black holes form to begin with? Normally, these types of black holes are produced by various type 2 supernova involving a much more massive star, but in this case, the second star should not really be in this position or in this unusual orbit. And more importantly, it's kind of difficult to explain the unusual eccentricity. Why isn't the orbit more circular? And so at the moment, these unusual black holes are most likely going to remain a mystery until more ESA's observations using Gaia telescope and the next data release planned for 2025. Because obviously the telescope is still collecting more data and is going to be sending even more in the next few years. And so at this point, the scientists are hoping to find even more of these objects, which might help us finally figure out exactly what happened in these star systems. And because, as I mentioned previously, this now does seem to be the most common type of a black hole in the entire galaxy, at least based on the evidence and the observations, trying to figure out their origins might help us understand a little bit more about the universe as a whole. But at least for now, that's pretty much it. Thank you for watching, subscribe, especially if you'd like to catch that video on ChatGPT in astronomy, and maybe share this video with someone who loves learning about space and sciences. Come back tomorrow to learn something else. Support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.